There were stories of monsters in the woods, not myths, but machines. If you were a radio hobbyist in the late 1970s, you might remember a sharp, relentless tapping on shortwave 10 times a second, walking across the dial like a woodpecker. It wasn't a fault in your set. It was a Soviet over-the-horizon radar announcing itself to half the planet. And the thing that made it was a wall of steel so big it changed the horizon. The antenna was called Duga. Built near Chernobyl, it wasn't a dish or a tidy tower. It was a steel lattice stretching almost half a kilometer, with paired arrays roughly 210 meters and 135 meters tall, the wider array approaching 300 meters across. Imagine a skyscraper laid on its side and then doubled. Engineers fed it with transmitter power in the multi-megawatt range, think small power station territory, to push a high-frequency pulse that bent with the ionosphere and came back over the Earth's curve. In theory, that let you spot a ballistic missile launched thousands of kilometers away, long before a conventional radar saw anything. Duga was part of a Soviet race to buy minutes, maybe tens of minutes, of warning in case the worst day of the Cold War ever arrived. The Americans were trying versions of this too. Over-the-horizon radar wasn't uniquely Soviet or uniquely absurd. It was a hard physics problem that both superpowers were willing to attack with money, steel, and patience. If you want an anecdote that captures the mood, here's one. When US reconnaissance satellites first photographed the Duga site, analysts measured the antenna's shadow on film to estimate its height. They weren't sure what they were looking at. Shipyard? Factory? Only that it was massive and it was aimed at the sky. Meanwhile, on the ground, shortwave operators from Canada to New Zealand filed interference complaints as the Russian Woodpecker ticked through their bands. The International Telecommunication Union took notice. For a while, it was the most famous mystery signal in the world. But Duga had problems you can't fix with bravado. The ionosphere is a living thing. It shifts with day and night, with seasons, with solar weather. The same variability that makes over-the-horizon radar possible also makes it temperamental. False returns, ghost tracks, and the constant tuning dance to stay on the ducted path. Add to that the enormous energy draw, the maintenance burden of a half-kilometer steel forest, and the awkward truth that software and satellites were catching up fast. Duga operated from the mid-1970s into the late 1980s. Then the money, the political will, and arguably the technical edge all ebbed. Today, the structure still stands inside the Chernobyl exclusion zone, rusting, climbable, and unmissable from the air. If Duga was the loudest, it wasn't the only giant. In central Siberia, outside Krasnoyarsk, the USSR began erecting a Daryal-class phased array radar. 2 solid faces, each rising like a 30-story building, backed by hundreds of thousands of cubic meters of concrete and mountains of rebar. Locals nicknamed it the Siberian Pyramid. Phased arrays don't rotate. They steer beams electronically, which sounds elegant until you see the price tag and the power feeds. This was supposed to be a next-generation early warning node. There was a treaty problem. The 1972 Anti-Ballistic Missile Treaty restricted where large early warning radars could go. They were meant to sit on the periphery, looking out, not in the middle of the country, looking over the horizon. Washington argued that Krasnoyarsk violated the ABM Treaty. Moscow denied, argued then, under perestroika pressure and a changing balance of costs and benefits, backed down. Construction halted. Later, demolition followed. What remains, footings, frames, faint scars, is a lesson in how geopolitics can cancel engineering at any stage of completeness. Not every Soviet mega antenna ended as a ruin. Travel north of Moscow to the Volga, and you'll find a survivor. The Kalyazin RT-64 radio telescope. The figures are clean. A 64-meter dish. A 4,000-ton rotating structure. Built from the mid-1970s, operational by around 1990, it's been used for deep space communications and VLBI astronomy. If Duga and Daryal were about the split-second politics of warning, Kalyazin was about listening. Quasars, interplanetary probes, the quiet work that shares hardware with military space tracking, but earns its living with science. The setting is almost cinematic. Kalyazin sits beside a river valley the Soviets deliberately flooded in the 1930s to build a reservoir. A Baroque bell tower from the drowned town still rises out of the water like a finger pointing to the past. Behind it, this colossal modern ear to the universe turns on its bearings with a low mechanical groan. It's hard to write a more Soviet frame, a relic of the old world and a monument of the new, both surviving by accident and maintenance budgets. If you add the pieces together, a pattern emerges that's more interesting and more fair than simple triumph or failure. Duga wasn't madness. It was a rational bet on a difficult technology that also seduced the West. It achieved part of what it promised, coverage, but at a cost in electricity, maintenance, and operational complexity that made it fragile in practice and vulnerable to better options arriving. The Krasnoyarsk Daryal wasn't uniquely Soviet waste. It was a treaty test, a statement, and a victim of shifting incentives as the Cold War cooled. And Kalyazin shows that the same industrial state that built radar walls also left behind a working instrument with a long scientific life, a rare, unglamorous win. For scale, let the numbers breathe on screen. Duga's paired arrays at approximately 210 mm and approximately 135 m tall. The receiver face near 300 m across. Transmitter power measured in megawatts. Daryal faces stacked like 30-storey blocks across a base the size of a neighborhood. Kalyazin's 64-meter dish turning a 4,000-ton deck with millimeter precision. Then add the quieter figures. Thousands of tons of steel that have to be painted, bolted, and kept aligned. Kilometers of coax and waveguide that hate winter. Megavolt feeds that hum whether you detect anything or not. There are human stories threaded through all of it. Radio clubs logging the woodpecker clicks in notebooks, trying to triangulate a signal that bounced off the sky. Satellite analysts with rulers on film, squinting at shadows to turn geometry into intelligence. Workers at Krasnoyarsk pouring concrete in Siberian cold, then watching policy erase their project. Technicians at Kalyazin catching a faint carrier from a deep space probe and cheering in a control room no one will ever film for a blockbuster. In the end, these mega antennas weren't just monuments to paranoia or pride. They were instruments trying to answer the most expensive question any government can ask. How much warning do we have? Sometimes the answer came with a clean return. Often it arrived wrapped in noise. And if you go looking today, you'll still find the hardware where the answers used to be. A rusted forest near Chernobyl, a scar in Siberia, and a great white dish listening to the sky over the Volga.